In this tutorial video, I'll be discussing how we are going to solve problems involving radicals. So come on, welcome to Agimath, and this is Agila. Before we go to the problems I prepared for you, let us first have the steps in problem solving. Number 1. Read the problem several times until you understand it. This is the most vital part in problem solving. You need to read the problem as well as analyze the problem. That is the most important. Second, determine what is being asked in the problem. We need to have a direction, a goal on what we are going to get. That is for step 2. Number 3, you need to devise a plan. So after getting all the information needed, we need to create how we are going to attack the problem. And we call it a plan. And then after that, you attack the problem. And then number 5, look back. Meaning, you check your answer if that answer can meet our problem. Okay, let's have problem number 1. A rectangle has a perimeter of 24 inches with a length of 4 inches and a width of square root of x plus 2 inches. What is the value of x? Okay, assuming that we already read it several times and we are done analyzing, then let's have the vital information one by one. We have the rectangle, so I'm going to draw a rectangle, a very beautiful rectangle. And then the next given is it has a perimeter of 24 inches. When we say perimeter, it means the distance around the figure. Or in other words, if we are going to add all the lengths of all sides, answer should be equal to 24. The next given is the length of the rectangle is 4 inches. Meaning, if this is a rectangle, we can denote this side to be the length and this side is equal to 4 inches. Since this is a rectangle, always remember that the pair of opposite sides are congruent. So if this is equal to 4, this is also equal to 4. How about this side? Since we are given with the perimeter, if we are going to add the length 4 and 4, that is equal to 8. And since we know that the perimeter is equal to 24, then meaning the sum of the two sides should be equal to 16. And since opposite sides are congruent, each side should be equal to 8 because it is a rectangle. Now, if you are going to add all the sides, 4 plus 4 is 8, plus 8, 16 plus 8, that is equal to 24. But, if we go back to the problem, it says that the width is the square root of x plus 2 inches. This side, according to the problem, is equal to square root of x plus 2. So meaning, x plus 2 should be equal to 8. But what is asked in the problem? What is the value of x? So we really need to solve because it is asking for the value of x. But if it is just asking for the width, how wide is the width, then we can answer immediately 8. But it's asking for the value of x. So we need to solve. Now, again, the square root of x plus 2 is equal to 8 as I explained earlier using the idea of perimeter. Now, in solving radical equation, it's very simple. If it only contains one radical expression, then you need to isolate radical expression away from the constant, and it's already isolated. So we can proceed to the next step. The next step is you look at the index of the radical sign, because not all the time it is just square root. There are times it is cube root or the fourth root. Now, if what is the index, that should be also the power that we are going to use to raise the radical expression, to get rid of the radical sign. Since the index is 2, we need to raise both sides by 2. Okay, we need to raise both sides by 2. Again, the purpose of doing this is to eliminate this radical sign. And recall that one of the properties of the radicals is this. If you have the nth root of a being raised to n, the answer is just equal to a. What does it mean? If the index and the power outside are equal, then it will just be giving us the radicand. So meaning, when we have the square root of x plus 2 square, it will just give us x plus 2, as shown in the property earlier. And then 8 squared is equal to 64. Again, what we are computing is the value of x. So meaning, we need to get rid of 2 on this side and transpose it to the other side by applying addition property of equality or subtraction property of equality. So we can have 64 minus 2. Or the idea of transposition, you transpose this to the other side, you change the sign to its opposite sign from plus 2 to minus 2. And 64 minus 2 is equal to 62. And that's it. But do not forget the last step, we need to look back. So we do the checking. In doing the checking, it's very important that you go back to the original. I say original equation, which is the square root of x plus 2 is equal to 8. And all you need to do is substitute what you got earlier, which is 62. So substitute x with 62. And you ask yourself if it's equal to 8. So to find out, we need to simplify. 62 plus 2 is equal to the square root of 64. Is it equal to 8? What's the square root of 64? That is equal to 8. So is it equal to 8? Yes. So if you got it equal on the last stage, meaning your answer, which is 62, is correct. Therefore, x is equal to 62. And that is problem number 1. Problem number 2. The square root of 3 less than a certain number is 4. Find the number. This is one of the most common problems when we say we're solving problems involving radicals. The square root of 3 less than a certain number is 4. Find the number. You cannot solve this problem if you are not going to start. So let us start. When you have is, the word is, it signifies the equal sign. So we already have the idea where is the equal sign located. It's in between this word. Phrases, the square root of 3 less than a certain number, and 4. Now, we have the equal sign. We start with the first part, the square root. So when we say the square root, we need to draw a radical sign with index 2. And we don't need to write 2 because that is understood. So what is inside the radical sign? Just follow of 3 less than. When you have this phrase, 3 less than, it means the operation is subtraction. And this number 3, it should be the subtrahend. Always, when it is stated like this, 3 less than, it means minus 3. From what? From a certain number. The problem with this is we don't know what is that number, and in algebra, if we don't know something, we represent it with a variable. So for example, n. Dili na tag x. We use n. Now the square root of n minus 3 is, so we have the equal sign, and then what? that is equal to 4. Okay. So the square root of n minus 3 is equal to 4. Now, after having the equation, then we are good to go. We solved the radical equation. Again, isolate the radical expression from the constant. And since it is already isolated, what we can do is to raise this radical expression to get rid of the radical sign by just looking at the index. Index is 2, so we need to raise both sides by 2. Again, what you do on the left side, you do on the other side to make it equal, to maintain the sense of equality. Now, applying the property I showed to you earlier, it will leave us with n minus 3. And that is equal to 4 squared. 4 squared is equal to 16. And solving for n, we apply transposition. N is equal to 16. Since this is minus 3, it will become plus 3 on the other side. And 16 plus 3 is equal to 19. And that's it. N is equal to 19. And the next step is to look back. Lumingon ka sa iyong pinanggalingan. We do the checking using the original equation. The square root of n minus 3 is equal to 4. That's why it's very important that the equation you create is correct. Because if this equation you formulated earlier is wrong, then all of these are wrong. So you analyze carefully the problem. Now we have the square root of n minus 3 is equal to 4. We just substitute with what we've got earlier. So n is equal to 19. So 19 minus 3, is it equal to 4? But what is 19 minus 3? That is equal to 16. But square root of 16, is it equal to 4? So what's the square root of 16? Square root of 16 is equal to 4. And are they equal? Of course. 4 is equal to 4. With that, we can conclude that the number is 19. And that is problem number 2. We proceed to problem number 3. Problem number 3 is very long and it's very nice. The longer, the nicer. The lateral surface area of a right circular cone represented by S is given by the equation S equals pi times r times the square root of r squared plus h squared, where r is the radius of the circular base and h is the height of the cone. If the lateral surface area of a large cone-shaped funnel is 364.25 square centimeter and its radius is 5.75 centimeters, find its height to the nearest hundredth of a centimeter. So, let's start. Let us dissect the problem. We start with the lateral surface area of our right circular cone. So, we are given with the formula S equals pi r times the square root of r squared plus h squared. So, the first sentence, it gives us the equation to be used. So it's very nice because we are already given with the equation. But later on, we realize that it's not nice, actually. Next, we have the surface area of a large cone-shaped funnel is 364. This is one of the given. Given that the surface area is 364.25 square centimeters. Next, we have the radius to be given by 5.75 square centimeters. And then what we are looking is the height. So this is the part we can say the given equation is actually not nice. Why? Because if you are going to look at the given equation, it is used in finding the area. But what do we need to find? The height. Meaning, we still need to derive the equation to be used before we can proceed with the before we can proceed with finding the height. Okay, again, I said that we need to derive the equation in finding h because we are finding for height. So in doing that, it's very simple. Have that mindset. It's very simple. All we need to do is to play with variables and think of getting rid of what we don't need at as of the moment. So you have s equals pi times r times the square root of r squared plus h squared. Again, what we are going to derive is the formula in finding h. So to do that, you need to remove everything together with h, including the square. But how are we going to do that? We need to start with the surface, the outer surface, which is pi and r, because it's outside of the radical sign. So to do that, since pi r times the square root of r squared plus h squared, the operation is multiplication, we use the reverse operation. So we need to divide both sides by pi r to get rid of pi r on this side. So what will happen? We need to divide both sides by pi r. Again, the purpose of that is to get rid of this pi r on this side. So we can cancel, and what we will have is s over pi r is equal to the square root of r squared plus h squared. So if you can observe from the original to this one, the pi r is eliminated on this side because what we want to solve is h, meaning it should be only h on this side. So we need to get rid all of this, the pi r, the radical sign, the r squared, and the square, the exponent 2 on h. But we are going to do it step by step, and to do that, you start with the outer surface, pinakagawas. Okay? So if you are going to look at the right side, because this is what we are focusing on, to get rid of all things, of all variables instead of h. So the next surface that we need to get rid of is the square root or the radical sign. And you can apply the idea I taught you earlier. Just raise it to the power equal to the index, which is 2. So we need to raise both sides by 2. Both sides by 2. So what will happen? We will have the square of s over pi r is equal to. So on this side, what will happen? The square and the radical sign will cancel. So what is left is r squared plus h squared. Then after that, because we are just solving for h, we need to get rid of r squared on this side by transposition. Because operation is just addition that separates r squared and h squared, we do not divide both sides by r squared. We just simply transpose or subtract both sides by r squared. So we will have s over pi r squared minus r squared is equal to h squared. And the final step, since we are looking for the value of h, we need to do the reverse of squaring, which is square root. We extract the root so that what will be left is just h. So we take the square root, but what's the square root of h squared? That is h. So now we have the formula in finding h. Okay, let me give you back the given earlier. S equals 364.25, R equals 5.75. Since we already have the formula, all we can do now is substitute. Substitute S by 364.25. Pi, in this video we are going to use 3.14, but we know that pi is irrational. But for the purpose of solving this problem, we just use 3.14. R is equal to 5.75, so that's why 5.75. And then just follow the formula. R squared, that's why we have 5.75 squared, is equal to h. to do this, because you are just allowed to use calculator, start with multiplying 3.14 and 5.75, and that is equal to 18.055. And to make our answers very near to accurate, we divide this one. 364.25 divided by 18.055, and then the answer, square it immediately using your calculator. So when I did that one, I got the answer 407.0091 subtracted by what is 5.75 squared. That is equal to 33.0625. And then just simplify. We can subtract 407 by 33, so that is equal to 373.9466, and then perform the square root using your calculator, and that will give you 19.34. And then for the last part, the checking, since I do not have enough area, you can do it by yourselves. You do the checking with the original problem. Thank you. Therefore, we have the height of the funnel is 19.34 centimeters. And that is problem number 3. Problem number 4. Given the equation V equals the square root of 2gm over r, derive the equation for finding r. So in this problem, we don't need to solve something, we just need to derive the equation for finding r. So we copy the given equation V equals the square root of 2gm over r. And then, since it involves radical sign or the radical expression, we just need to apply the idea I taught you earlier. You raise both sides by a power equal to the index, which is 2. So we raise both sides by 2. So in raising both sides by 2, what will come out? We will have v squared, because v squared is v squared. And then raising this radical or the square root of 2gm to r, it will give us 2gm over r. So the radical sign is gone together with the exponent 2, because that is one of the properties of radicals. Now, to solve for r, I'll teach you the shortcut. Let us apply this property. If a over b equals c over d, then d over b equals c over a. Observe what happened. From a over b equals c over d, what happened is we interchange a and d. So from a here, it is being transferred to as the denominator of c. And then from being the denominator of c, it becomes the numerator of b. So that property is alternation property of under the properties of proportion. So we can really use this one so that it will be faster. So we can have the to show you, to make it clearer, we write v squared as v squared over 1 so that we can have this form. And then apply the alternation property. Since we are looking for r, we want r to be on the other side or to be isolated with the remaining variables. So we can apply alternation property. V squared and r, we exchange their positions using alternation property. So what will happen? We can have r equals 2gm over v squared. And that's what we are looking for, the equation for finding r. And that's it. And that is problem number 4, and that is the last problem. So thank you for listening and understanding the given examples. Do not forget to like and to comment below. This is Aguila saying thank you so much. Bye-bye.